This is my presentation. As Dr. Rinan introduced me, I work at the Department of Animal and Aquatic Science in Chiang Mai University, Thailand. I met Dr. Rinan, Dr. Avin in Kochi, and we been a good friend. And I hope in the future, both of them will give the opportunity to join my class in the future. And for this subject, actually, I teach the same subject as the Renan. I hope in the future we can join the class again. This is my research when I was a PhD student in Kochi University. I work with red sea bream. I spent 3.5 years to research. So it's like a series of my research. And for my presentation, I will focus on the enzyme, digestive enzyme activity, rather than talk about a whole research. As this subject, it's the basic knowledge for the bachelor students. So I don't want to make it too difficult for students. All right, and so I try to improve the nutritional quality of soy protein concentrate. It's the product of soybean for red sea bream. And this red sea bream, some of you may know this type of the species is the carnivorous. They live in the marine. And this type of species is one of the economical fish species in Japan. And it requires quite high protein content in the diet, over 45% actually. But the most important, the fish species is yellowtail, and the second is breastfeed, that is fish. And I decided to pick this fish because I just got in love with them, and they were so cute. And for this fish, as they require high content of protein, that means for fish, we use the fish meal as the main protein in the diet. And for this fish meal, its price is very high and been increasing every year by year. So this problem caused the high cost of the production in aquaculture. So we need to reduce the feed cost for the aquaculture production by finding the suitable protein alternative source. Then we found that the soybean, according to the many studies, found that the soybean meal is the good replacer to the fish meal. That's why we use it, because of the sustainable supply, and also cheap cost. That's the main reason. But for soybean meal, it contains quite high nutritional factor and also low protein content. So if we feed them a lot, fish will not grow, and that's why we have many products made from soybean, and one of them is SPC, soy protein concentrate. This soy protein concentrate contain high protein and contain lower nutritional factor compared to the soybean meal, and also a sustainable supply. But the negative side of the soy protein concentrate, it's it's not delicious. It's very low palatability, so it causes the low feed intake if we feed to them. And the main reason that we don't use it a lot, they cause the low growth performance if we feed them a lot. So my research, I try to develop the diet that contains no fish meal at all, by using the SPC or soy protein concentrate as the main source of the protein in the diet. To achieve a goal, I need to enhance the feed intake by improve the palatability to make the diet more delicious. And also I need to find the reason of the raw growth in the fish fed SPC diet. To do that, I had to run so many experiments and to improve. Finally, I succeed. But today I will present or talk about the experiment until experiment 3. So the first one, I need to compare, the ingredients, SPC diet, if SPC diet can be digested by fish or not. And then we need to find out if we feed the fish by SPC diet for a long period of time, the fish can grow well or not. And experiment 3, we use the feeding stimulant to enhance the feed intake, make fish to eat more, and also fish need to digest the diet more as well. In experiment 1, we compare the postprandial free plasma amino acid and compare the protein digestibility between fish-fed SPC and FM diet. In this experiment, we used 2 experimental diets. One, the control is the fish meal. So in this diet contains 60% of fish meal. For SPC, we use 63% of SPC. As you can see, we use no fish meal in this diet. As you know, some of you eat the tofu. How do you feel about that? So the tofu is not delicious. That's why we need to use the feeding stimulant to enhance, to improve the taste for this experiment. And then we fed the fish for 2 weeks, and then we started to collect the plasma after 0. That means before feeding. And then after 3, 6, 12, 8, and 24 hours after feeding, and then we centrifuge the plasma and check free amino acids in the plasma. And at the same time, we collected the fecal for the protein digestibility measurement. We measure the dry matter and the protein content in the feces. This is the result. This is the free plasma amino acid. As you can see, the upper line, all of them are the SPC fed fish. You can see that the plasma-free amino acid of SPC fed fish become comparable to FM diet. So this one as well. And also the result of digestibility. You can see no different between among of the treatments. So that means digestibility of SPC diet was comparable. We can conclude that red bream can digest and also utilize the SPC protein very well. And the reason of low growth may be not associated with the protein digestion. That's what we found. So that means we can use SPC as the main protein source in the diet for red bream. For the second experiment, after we conducted a short feeding experiment just for 2 or 3 weeks, then we continue conducting a long period, a long feeding experiment. In this one, we use the pair feeding experiment. That means 2 treatments were fed at the same amount to find out if low growth was due to low feed intake or not. As the beginning, I told you that feeding the soy protein concentrate always cause low feed intake that result in low growth. For this experiment, we still use the same experimental diet as the experiment 1, but we have 3 treatments. The first one, the fish were fed control diet as the fish meal diet. They were fed until satiation, and then the other group were fed with SPC diet until satiation as well. And at the second group, the FM pair or fish meal pair group were fed the same amount as the diet as the SPC fed fish. They were fed until 6 weeks. So we terminated the experiment at 6 weeks because we found something significant. then we stop the feeding experiment. And we measure the growth performance, we look at the chemical composition, we also measure the nutrient retention, plasma, digestive enzyme activity as well. This is the result of the feed intake and the body weight. As you can see, the SPC the SPC fed fish were fed until satiation and feed intake were low, and for the FM pair diet were fed the same amount as SPC. But when you look at growth performance, you can see SPC shows significantly lower than other groups, even though they were fed the same amount of the diet as the fish meal paired group. So this indicates that the low growth is not just simply by the low feed intake. And then when we look at the weight gain as percentage, we see that the SPC fed fish had lowest weight gain. And at the same time, we can see the SPC diet has the higher feed conversion ratio. This parameter means you eat food, you eat the diet, but you don't grow up. That means you eat more, but you don't grow up. That's why the FCR become higher. This is the meaning of that. So according to this result, we can say that the raw growth in this case caused by feed utilization as well. And this is the result of plasma lipid and the visceral fat. I mean the fat the body cavity. And you can see the SPC diet had the significant highest plasma lipid and also the lowest visceral fat. That can be confirmed that the lipid utilization may be low in SPC diet. After two experiments, then we found that the reason of low growth that we aim to know at the beginning, we found that it's not just simply by the low feed intake, but also low feed utilization. So that means they eat a lot, but they don't grow up. This is the meaning. In experiment 3, I try to use the feeding stimulant to enhance not only for the feed intake but also digestive enzyme secretion, because we understand that if the animals secrete more the digestive enzyme, that means they can digest more and absorb more the nutrients so that they can grow up. But in case of SPC fed fish, the digestive enzyme secretions always low. That's why the feeding stimulant is used for this experiment. According to our previous experiment in the same lab but conducted in yellowtail, we found that after using the feeding stimulant, as you can see right here, the feeding stimulant can enhance the digestive enzyme secretion. That's why I think at that time I thought if we use the feeding stimulant, we can enhance the digestive enzyme secretion so that fish can digest it more nutrient food. So in this experiment, we're divided into the small trials. The first one, we tested the synthetic feeding stimulant. We used like high omega-3 amino acid supplement to the diet. And the second trial, we used the synthetic and compared to the natural feeding stimulant, and this time we use the fish meat hydrolysis. And the first experiment, we used the diet without synthetic feeding stimulant, and the second one we supplemented with the synthetic feeding stimulant and fed to the fish. And the second trial, we used the synthetic compared to the natural feeding stimulant. In this trial, we fed the fish and then we collected the samples such as the digesta and the liver. As you can see the figure right here, this is the digestive tract of the red sea bream. We collected the digesta. Digesta is the diet that ingested and digested by the fish and kind of the feces in the intestine. And this is the reflection of the digestive enzyme. And for the liver, we believe that, not believe, we know that the digestive enzyme is usually synthesized and stored in the liver. The reason why we collected the liver. And then we measure the trypsin and lipase activity in both kind of the sample. Okay, let's see the result of the first trial. We compare the diet without the synthetic feeding stimulant and the other one supplemented with feeding stimulant. And this is the trypsin activity in pyloric digester and lipase in pyloric digester. The fish, these samples were collected right after feeding. That means we fed the fish and we collected the sample. And the other one is the 4 hours after feeding. That means we fed the fish for 4 hours, then we kill and collect the sample after 4 hours. At the black column right here, this is the diet without the synthetic feeding stimulant. Here you can see the fish fed synthetic feeding stimulant secrete more lipase in the pyloric cigar and also in the intestinal digester. This we found a significant difference. And according to this result, it indicates that the synthetic feeding stimulant has the potential to stimulate the secretion of digestive enzyme. For the second trial, we compared the synthetic feeding stimulant to the natural one. This graph, this is the trypsin activity in hepatopancreas. We found that the hepatopancreas, as I said, the liver synthesize and store the trypsin inside, and then they secrete. That's why we found that the lower activity of trypsin become lower after feeding. And for intestinal digester, we found the increasing of natural feeding stimulant after 4 hours after feeding. So we can say that natural feeding stimulant is more effective to the stimulant secretion of trypsin. And also we found a similar tendency, similar what happened in lipase activity in the hepatopancreas and also intestinal digester and pyloric digester. So we confirm that natural feeding stimulant is more effective to stimulate the secretion of lipid. Based on the result in this experiment, we can conclude that the synthetic feeding stimulant could stimulate the secretion of digestive enzyme, and compare between natural and synthetic one. The natural feeding stimulant is more effective to compare to the synthetic feeding stimulant. In experiment 4, 5, and 6, I'm not talking about them today, but finally, for this long experiment, this research, we found that the synthetic, if we use the plant protein source for the red sea bream, then the feeding stimulant is very important to enhance the palatability, and it may affect the digestive enzyme secretion. And if you are interested in my research, you can follow my publication. This is the first one. In experiment 2, I published one paper, and the second one about the natural feeding stimulant, we had one more paper. So that's all for my presentation today. Thank you for your attention, and if you have any question, please do not hesitate to ask me. Thank you.
Okay, thank you very much, Dr. Tola. So any question from the audience, student? I think we could entertain at least 2 because Dr. Tola is quite busy right now and she's attending some important matter. So from the group?
Any questions? Zora, I
question.
still have 5 minutes.
Anyone? So, okay. So, Dr. Tola, have you look look at the because here in the Philippines, the aquaculturists, they look at the which of these, although we can look at that in compared to fish meal, the soy protein concentrate shows a potential, but what about the economic side of this? Because probably the SPC might cost higher compared to fish meal, so it would be disadvantageous to the business sector, to the aquaculturists. So have you looked at that side of the uh, experiment?
Right, and if we are talking about the cost of the SPC, of course, it's very expensive. And we also after this experiment, after this research, when I moved back to Thailand and I continue another research using the feeding stimulant in Asian sea bass. In Asian sea bass, or another name is Balamandi. It's one of economical fish species in Thailand, and they it also require very high content, like in the same concept as red seaweed. But in this research, I didn't use the SPC, but I used soybean meal and supplemented the fish tuna hydrolysis. So as you said, the cost of the SPC diet is expensive. So using this feeding stimulant to the plant protein, I think the knowledge from what I found from my research can be applied to another type of the plant protein. But the main point, as I said, we use the plant protein. The main problem is palatability. And if we found some other negative effect of the plant protein, then we can continue to fix it. And for soybean meal, we also have another research. We try to improve the quality of soybean meal compared to SPC, but we also consider about the process and the cost of the processing to make to improve the quality of the soybean meal compared to SPC.
Oh, I see. So thank you very much for that explanation. So I think on the other side, if you look at the on the conservation side of the study, so considering that the fish meal supply is already dwindling, so if the production is getting lower, so the source for fish meal could be problematic in the future. So I think this study could be an alternative for that.
Right.
So that's a very good insight. So
Yeah, that is the main idea. Yeah, to conserve the fish meal, try to use less and try find alternatives of which is sustainable supply and unlimited. That is the main idea.
okay, so thank you very much.
You're welcome.
So I would like to acknowledge Dr. Tan. He's already Dr. Tan. You remember Dr. Tola from USA?
Nice. Okay, thank you.
Of
Everyone.
course, cook for me. He cooked for
Yes.
me when I was in USA.
Bring me many ham from USA to Asakura.
And the motivate. It's nice to see you guys again.
Okay, so thank you very much, Dr. Tola. So it's okay, Dr. Tola, if you are be having another activity. So it's okay to if you want to leave the group.
Thank you so much, and thank you for having me today. And I hope in the future, you guys can attend my class.
Yes, I'd love to.
Okay, you own me.
Yeah,
Okay, have a wonderful day.
yeah. Thank you
And
Thank
very
you,
much
Tola.
again.
bye. You're welcome. Bye bye,
Jonas.
Alisang. Bye bye,
Bye.
bye
Bye,
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 students.
bye.
Bye.
Okay, so uh, I would like to acknowledge the presence of Dr. Tan from uh, Vietnam National University. So I think Dr. Tan is